Just have to look at which field it's on.
And more specifically, the limits that were indeterminate. All right, indeterminate forms of the limit. We've seen these before. Indeterminate forms of a limit are when the limit equals 0 over 0 or infinity over infinity. There we go. And when that happens, sometimes there are algebra tricks that we know that will work, like factoring or taking the ratio of the lead coefficients is another one. But sometimes none of those work, although we will review them today. The other way to handle it is L'Hopital's rule. French mathematician, hence the name L'Hopital. You gotta say it with some flair. Let's first review the indeterminate forms that use algebra tricks. So this sort of eases us into the review, but also eases us into L'Hopital's rule. So limit as x approaches -1, 2x squared minus 2 over x plus 1. So what's our first attempt when it comes to limits? What's our first try? Yeah, plug in -1 and see what happens. So if I plug in -1, I get, let's see, 2 minus 2 is 0 over 0. So that's an indeterminate form, because I don't know what 0 over 0 is. Right? There's like two conflicting rules going on there, right? You can't divide by 0, but if 0 is in the top, it equals 0, so we don't know what's happening here. So let's use one of our algebra tricks. Let's factor. I can take out a 2, and then I can factor x squared minus 1. The x plus 1s will cancel. Is this vaguely familiar from long, long ago? Plug it in first, it doesn't work, then you gotta try some gymnastics here to make this happen. Now let's plug in -1. 2 times -1 minus 1 would be -4. All right, that is not L'Hopital's rule. That is like first 9 weeks stuff there of remembering how to handle limits. Example number 2. Again, not L'Hopital's yet. Limit as x approaches infinity. 3x squared minus 1 over 2x squared plus 1. Well, if I plug in infinity, I get infinity over infinity, so that's not really helpful. Like, I don't know what that is. It won't factor. Do you remember the rule there, though? What that limit's going to be? Something about coefficients. That's pretty good. Top no. What's the rest of that? Bottom O and equal co. What? So what situation is it? So it is equal co. What's equal? Yeah, the degrees is what we're looking at. So what does co mean? So they have equal degrees, but what does co mean? 3 over 2, the coefficients. So 3/2. Again, not L'Hopital, we'll get to that in a minute, but it was an indeterminate form, and we knew a trick to figure it out. L'Hopital will also work on that one, but it's probably easier to just know the algebra trick. All right, limit as x approaches 7, square root x plus 2 minus 3 over x minus 7. Well, plug in, see what happens, but 0 over 0. So I don't know yet. Do you remember the algebra trick to make this one work? I want to multiply by something. Not reciprocal. Did I hear the word over there? Conjugate. So let's change that middle sign. And conjugates are supposed to make the square roots go away. Whatever I multiply to the top, I got to multiply to the bottom. So in the top, root x plus 2 times root x plus 2 would be x plus 2. The outside and inside of FOIL are going to cancel each other out because we multiply by the conjugate. That's what the conjugate does. That's why we multiply by the conjugate, to make the O and the I cancel each other out. And then negative 3 times positive 3 is minus 9. In the bottom, you might remember that we don't actually multiply. I mean, we are multiplying, but we're not going to multiply it out. We're just going to leave it like that and hope that something cancels out. And aha, as always, x minus 7 over x minus 7 cancels out. So let's try again on the substitution now. So 1 over square root of 9 plus 3. And I'm out of space, and so it's a good time to remember that safe stops are perfectly acceptable. So as maybe weird as that looks, it's okay. 1/6. But I'm out of room, so we'll employ the safe stop. So that was a brief review of algebra stuff from long ago on dealing with indeterminate forms, 0 over 0 or infinity over infinity. All right, Mr. L'Hopital came up with another way to handle the indeterminate forms. And here's his rule. If the limit as x approaches a of f of x over g of x is indeterminate, meaning 0 over 0, or infinity over infinity. It's like you can't determine what it is. It's indeterminate. Then, the limit as x approaches a of f of x over g of x so here's his alternate way of finding that limit, is the limit as x approaches a of the derivatives, f prime over g prime. Derivative of top, derivative of bottom. This is not the quotient rule, so there's not, that gf prime minus fg prime all over g squared. It's not that. It's, you handle them separately, so it's easier than the quotient rule. Derivative of top, derivative of bottom, and then evaluate that. And these two things will have the same limit. And so by taking a derivative, sometimes you get rid of the indeterminate form, and you get something you can use. Let's do an example. limit as x approaches 0 of e to the 3x minus 1 over x. Now, we have to be careful when it comes to writing this stuff out. Like, this is one place where the calculus AP graders get kind of picky, because 0 over 0 and infinity over infinity, because those are indeterminate and they don't really exist, you can't really write those down. So you have to be careful how you express that this is indeterminate. So if you write equals 0 over 0, that's not correct, technically, even though we know what you're doing. So the best way to kind of do it is to maybe just like arrow the top and arrow the bottom. So I'm not making a mathematical declaration here. I'm just checking things out. If I plug in 0, I get e to the 0 is 1, 1 minus 1 is 0, and in the bottom I get 0. So I've kind of shown that it's 0 over 0, but I can't say that it's 0 over 0 because 0 over 0 doesn't work. So it's just a technicality thing they kind of harped on in the last few years. And so we'll say, therefore, it's indeterminate. And we'll use L'Hopital's rule. And you need to say that. So you got to tell them that it's indeterminate, and because it's indeterminate, I'm going to use L'Hopital's rule. Basically, you can't use L'Hopital's rule if it's not indeterminate. So if you like get excited, like, oh, this is a great rule, I'm going to use it for everything. Like, no, you're only allowed to use it if it's 0 over 0 or infinity over infinity. So if you get the answer to be 3, well then stop. You don't have to use this. Once you show that it's 0 over 0 or infinity over infinity, then we can take the limit of the derivatives. So the derivative of e to the 3x, we're on video, so I won't pull a popsicle stick and put anybody on the spot. What's the derivative of e to the 3x? Good, e to the 3x, chain rule times 3. How about the derivative of minus 1? Nothing, 0. That the derivative of a constant is 0. The derivative of x, 1. All right, so let's try again, plugging in 0. 3 e to the 0 over 1 would just be 3. So as long as the derivatives themselves aren't really difficult, this is a pretty easy method for evaluating limits. Take the derivative of the top, derivative of the bottom separately, not quotient rule, and then try again. Let's do another example. Limit as x approaches infinity of x squared. You know what? Let's make it x approaches negative infinity of x squared over e to the negative x. So the top would go to, if I square infinity, I get infinity. The bottom would be e to the negative negative infinity, which is infinity. So I can't say it equals infinity over infinity because that's not really anything. But I've shown that it's infinity in the top and infinity in the bottom. So I need to write indeterminate. I mean, I guess at the very minimum, indeterminate, therefore, L'Hopital's, LHOP. That's probably as little as you could get away with writing for them to know what you were doing. You know, part of the AP test is communicating what you're doing. The free response question is, anyway. So let's take derivative. Limit as x approaches negative infinity. Derivative of x squared. Should put somebody on the spot for that one.
Yeah.
2x. Derivative of e to the negative x would be negative e to the negative x. Let's try again. So the top is going to go to negative infinity. The bottom is going to go to all sorts of negatives, but also negative infinity. Bah, so that's still indeterminate. So let's try L'Hopital's again. Basically, you can keep going, especially if you can sense that you're making progress. Like, we're not making any progress on e to the x, like that's going to just stay e to the x. But the top is changing on us, so let's try again. Limit as x approaches negative infinity. Derivative of 2x would be 2. Okay, that's good news. So the top's not going to be 0, or not going to be infinity anymore. Over e to the negative x. So if I plug in infinity, I get 2 over infinity. But what's 2 divided by a really big number? 0. So my answer would be 0. But I had to apply L'Hopital's rule twice. So it's a pretty easy way to handle limits that are weird. So the first time we did this, the only way we had to handle weird limits was algebra tricks. Why could we have not used this method in that first month of school, or first 6 weeks of school? We didn't know what a derivative was. So there was a better way, but we didn't know what derivatives were, so we were just stuck using algebra. So now we have another tool to handle limits. All right, I'm going to give you the worksheet. I'm going to give you some hints on a few of them. The worksheet today has today's assignment, but it also has a review on the back. And we may as well start talking about what's due on Thursday. Let's say 4 out of the 5. So there was a worksheet on the area between curves. Top minus bottom, from left to right. There was a worksheet on the volume of cross sections, or volume with cross sections. There was a worksheet on disc and washers. That's what we did at the start of today. We did one of those. And then there's a worksheet on L'Hopital's rule and a review worksheet. This is actually on the same piece of paper. One page, one piece of paper. I don't know how to say that. It's 2 different assignments, even though it's on the same piece of paper. Does that make sense? So it counts as 2 assignments. Okay? Also on the review, I pulled an old quiz and I forgot to change the label, so it says quiz, but it's just a review. So don't worry about the quiz element of it. So tomorrow we'll have time to review, to go over anything we need to, and then Thursday we'll test. Let me pass out the limit worksheet and give some hints on it though. All right, so look at the directions first of all. On 1 through 3, find the limits using techniques from chapter 1. AKA August, algebra tricks. And then part B, do the same thing but L'Hopital's rule. And you should arrive at the same answer. Now, a couple of hints, like look at number 14. Limit as x approaches 0 from the right. Let's see, natural log of 0. Natural log looks like that. So 0 from the right of natural log would be negative infinity, and x would approach 0. So that doesn't look like it's an indeterminate form because it's not 0 over 0 or infinity over infinity. But you can do a trick. and rewrite it as negative natural log of x over 1 over x. Right, that's the same thing algebraically, we just wrote it differently. But now it's infinity over infinity. And so now it's sort of eligible for L'Hopital's rule. Same thing on number 15. As x goes to infinity, we'd have infinity times sine of 0, and sine of 0 is 0. But if we change that to sine of 1 over x over 1 over x, again, I'm not really allowed to write 0 over 0, so I'm trying to say that without writing it. So now it's eligible for L'Hopital's rule. And then lastly, 17, I don't know that you need a hint. How do you think you should, what do you think you should do on 17? Any thoughts looking at that? Okay, so you can factor the bottom of this one. You're still getting 8 over 0 minus 2 over 0, which doesn't really make sense yet. How would we subtract them? So you're right. Find a common denominator. If I want to add fractions, I need a common denominator. So get a common denominator, add them, and then see if that cleans it up for you, and it should. All right, answers are at the bottom. And then the back, again, it says quiz. You could just, if it makes you feel better, mark that out and write review. And it's not much of a review. It's a pretty brief review, but there's kind of one of everything. There's a area problem is number 1. Number 2 is equilateral triangle cross sections. 3 and 4 are volumes of revolution. So it's a brief review. It's kind of just one of each thing to remind you of what's going on. I'll have more information about the test tomorrow, and then I'll take questions from anything tomorrow, and we'll be ready to test on Thursday.